Good morning, everybody. Today we're going to be talking about correlation basics, or looking at relationships between two different factors. So this is the kind of statistic we use not if we want to look at group differences to see if this group differs from this group on some kind of outcome, but to see how two variables go together. In this case, we're going to start out by looking at linear relationships. Do we have variables moving in one direction consistently, such that when one of them goes up, the other one goes up? One goes down, the other goes down, or they could be moving in opposite directions. As this one goes up, this one goes down, and vice versa. So to get started with correlations, we're going to be looking at the blue and white PowerPoint slides to get us started. I'm going to move down here in the corner so that we can kind of let the PowerPoint take center screen. And we want to remember that by the end of the time with correlations, we should be able to do these two kind of things. We should be able to identify the strength and correlations between factors, describe 4 types of correlations that we can use to look at the relationship between variables: Pearson, Spearman, point biserial, and phi correlation coefficient. Although we're only going to learn how to calculate Pearson and Spearman, I want you to know that other kinds are out there. We'll talk about the assumptions of correlations. Homoskedasticity, that's a great word to drop at parties to look really smart. Linearity and normality, and explain why these are necessary to interpret a correlation correctly. Explain how things like causality, outliers, and restriction of range can limit or affect our interpretation of significant correlations. Compute correlations using SPSS, interpret them within our hypothesis test steps, both for Pearson and Spearman, and summarize our results in APA format. So today we're going to do correlation basics, kind of getting us started. In the statistic we've learned so far, we've been looking at how to compare groups for differences. When we did z-tests recently, we were looking to see how this person differed from the group, or how this group differed from the group. Now we're going to be looking at how two variables go together, the degree of correlation or relationship. If we have a positive correlation, this means the two factors are moving in the same direction, up or down. As one increases, the other increases. As one decreases, the other decreases. The other kind of linear relationship we can have is a negative relationship. As one goes up, the other goes down, or vice versa. So a correlation is a statistical way that we look at this relationship or covariation between two variables. How do they vary together? And we use the R letter to symbolize a correlation. Symbolize? Yeah. R represents our correlation value. And sometimes we'll see a little S down here if we're talking about that Spearman correlation, but this is the letter that we have that represents that relationship. So again, a relationship exists between two variables when one changes in a constant or predictable way with the other one. When we look at correlations, the value that R can be is anywhere from -1 to +1. Right? If we imagine that R is in the middle, if two factors were not related, if they didn't have anything to do with each other, that R value would be 0. And if we have a strong relationship, right? Strong can be either positive or negative, but that number is going to be further from 0 out towards 1. 1 is the boundary. This is like the upper limit. You can't have a correlation value of 1.57. You can't have a correlation value of -3.6. So remember those limits. R has to be between +1 and -1, right? That's how far it has to go. So our number gives us a degree of relationship. We also can see how that would give us an idea of strength. Some researchers prefer to square that to get that R value to get a measure of strength. Others just use the R value itself. So we're going to look at how to kind of translate math to English and figure out how that R value as a number tells us something as a concept about the strength of that relationship. So we'll use a mathematician named Cohen who suggested that we can translate our effect sizes, again about strength, not direction, of that relationship based on its numbers. So if we get an R value that is between 0.1 and -0.1, so here in the middle, right? That's going to suggest we really don't have a relationship between the two factors. We would say no correlation. If we get something between 0.1 and 0.3, either on the positive side or the negative side, we would call that a small effect or a small relationship, small letter S here. If we get a relationship between 0.3 and 0.5, positive or negative, we would consider that medium or moderate. And if we get something bigger than 0.5 or smaller than negative 0.5, this is a large relationship or a strong relationship. So remember that a relationship can be strong and positive, or a relationship could be strong and negative. So strength is about being further away from zero, whether it's on the positive or negative side. Now, if we look at a value of a correlation graphically, we do that in what's called a scatterplot. A scatterplot helps us see the relationship for each person between those two variables. So if you're doing a hypothesis test and you want to pick a graph that shows relationship with both of those variables included, a scatterplot is the way to go. So each person on your data set is going to be a dot here on the scatterplot, right? So person A had a score of 31,000 for family income, and then had a grade point average, a grade average maybe on an exam or something of a 72. So here's person A. Person B is up here, and so forth. And that scatter plot again shows us how well those two variables go together. Remember then that again with correlations we're looking for the size or strength of the relationship. We also need to know what direction it's moving in. And then eventually we'll also want to look at its probability or the likelihood of getting that kind of relationship in our data set. So positive, things are moving in the same direction. Sometimes this is also called a direct relationship. And this negative relationship means that things are moving in the opposite direction. Sometimes this is called an inverse relationship. We can kind of tell the direction of the correlation by looking at the scatter plot. If we imagine a line that goes through the middle that shows us the correlation value or the average amount of relationship between those two things for people, we can see how everybody's dots cluster around that line to figure out if it's a sort of positive thing. Maybe if we had a relationship where as people's income went up, their weight also went up, this would show a positive relationship because that cloud or cluster of dots is moving from the bottom left to upper right. And if we saw a negative relationship, we would see that cluster of dots if we sort of drew a boundary around it or imagine a line that went through the middle that was going from the top left to bottom right. Okay, this would be showing a negative relationship. If the more your income went up, your weight went down, we would see the cloud go this way. So again, the most kind of common relationships that we're looking at with correlations is called a linear relationship. We want to see if things are moving in the same direction overall. There are other variations of correlations that we'll talk about in our next segment, but mostly we're going to be looking at these linear relationships for what we're learning for our class. If we had a linear relationships between things that was perfect, that for every increment of x that went up one step, we went down one step in y, right? Then all of our dots would fall in a straight line. It would actually be on that line. This would be a a negative perfect relationship. -1 shown here because all those lines, dots go together in a straight line. If we've got a fairly strong correlation, we'll have a small cloud of dots. All right? Small cloud of dots means a strong relationship. They're all moving in approximately the same direction. And the further out the cloud of dots gets, the weaker the relationship gets. So this one here is probably a correlation of about 0.8 if I'm ballparking. This one maybe about -0.3. And this one with a big cloud, round cloud that looks like a chocolate chip cookie, this is probably pretty close to 0 because we can't imagine a line going through it. Two things don't seem to be doing any kind of connection between each other. The last thing in this segment for today is we'll look at a correlation matrix. Once we get that correlation value, represented by the letter R, which talks about the degree of connection between the two things, we actually could show that relationship in a sentence, or we could put it in a table. And here what we've got with a matrix is a relationship between several different things at the same time. So if we had three concepts we were interested in studying, let's say looking at relationships between the amount of sleep people get, how much partying they're doing, and their grade point average, we could look at the relationship for each pair of factors and get a correlation for each set. So in this table, each of these values is a correlation value. This is a correlation value, also known as a coefficient. This is one, and this is one. So here, we're seeing that there is a negative, moderate relationship, this one's large, a negative large relationship between sleep and partying. When people tend to get less sleep, they're doing more partying. When they are partying less, they tend to get more sleep. This one shows a small positive correlation. When people get more sleep, they tend to have higher grade point averages. When they have higher grade point averages, they tend to get a little more sleep. And this one is moderate and negative. If you're doing a little more partying, you probably have a little lower grades. If your grades are higher, you're probably doing a little less partying. So again, moderate, negative relationship here. So we can tell the strength just by knowing how big this number is, how far it is away from zero. Now, in the next segment, we will look at different types of correlations. We're going to focus in on Pearson and Spearman, and we'll also talk about some of the restrictions or assumptions we need to know about with correlations to make sure that we're interpreting them properly. So, stay tuned on the next section for correlations part 2.